The thing you need to know is that I is equal to the square root of -1. I is our imaginary number. And so we can simplify negative square roots using that. Okay. And standard form of a complex number is a plus bi, where a and b are numbers, and I is your imaginary number, which works a lot like a variable. Okay, so if we look at -5 plus the square root of -9, we need to put that in standard form. Okay, and it's already kind of close to being in standard form if we look at standard form being a plus bi. So obviously our a is going to be -5. We need to simplify this square root of -9 to make it look like in the form bi. Okay, so I can simplify the square root of -9 to be the square root of 9 times the square root of -1. Okay, I can break that into two different square roots because -9 is equal to 9 times -1. So then if I simplify that further, square root of 9 is 3, square root of -1 is number I. Okay, and then if we bring down our a, we get -5 plus 3i. So a plus bi turns into -5 plus 3i. Okay, we're also going to look at the properties for adding and subtracting, multiplying, and dividing complex numbers. So if we're going to add two complex numbers, a plus bi, to c plus di, what we do is we add our first two numbers, so the a and c, and then we add our coefficients to our I, so the b and d, and the I stays the same. So we end up with a plus c and b plus d. Okay, and when we subtract, it's very similar. If we're subtracting two complex numbers, a plus bi minus c plus di, we have to subtract our first two numbers, our a and c, so we get a minus c. And then we subtract our numbers in front of our imaginaries, so b minus d. So we get a minus c plus b minus di. Okay, notice the sign in the middle stays a plus sign though. Okay, so let's look at adding and subtracting some complex numbers. So if we're given the example 4 plus 7i plus 1 minus 6i, we're going to need to add our first two numbers. So we add our 4 and our 1, so we get 4 plus 1. Plus, then we go to our second number, 7, and the -6. So 7 minus 6, and the I stays in the back. So then if we simplify that, 4 plus 1 is 5, plus 7 minus 6 is 1, so we get 5 plus 1i. Okay, if we look at 1b, we have 1 plus 2i minus 4 plus 2i. Okay, so we start with our first numbers and we subtract those. So we end up with 1 minus 4. Then if we go to our second numbers, 2 and 2, we end up with plus 2 minus 2i. Because this always stays a plus in between them. So then 1 minus 4 is negative 3. 2 minus 2 is 0, I. And so this just simplifies to negative 3. You don't have to write the 0, I. Okay, let's do one more like that. So we have 3i minus negative 2 plus 3i minus 2 plus 5i.
Reward is not. I want $100. That's just.
Okay, so let's start with, this is like a 0 plus 3i. We have no number in front of our 3i. So if we start grouping our first numbers, we have a 0 minus negative 2 minus 2. So 0 minus negative 2 minus 2. Those are our first coefficients, plus, then we have a 3, and a 5. So 3 minus 3 minus 5, I. Okay, so this minus and negative simplifies to a plus. So I get 0 plus 2, which is 2, minus 2, which is 0. So I end up with 0 total. Plus 3 minus 3 is 0, minus 5 becomes negative 5, I. And so this totally simplifies to negative 5i, because you don't have to write the 0. It gets hard? Well, good. We're going to start multiplying, which is also very easy. So we have 4 times the quantity negative 2 plus 3i. So we just distribute. So 4 times negative 2 becomes negative 8. 4 times 3i becomes 12i. So we get negative 8 plus 12i. Multiplying is very straightforward. When we're given 2 polynomial imaginary sets, then we get 2 minus I times 4 plus 3i. And just like if those were x's, we're going to FOIL. So first times first gives me 8. Outside times outside gives me 2 times 3i is 6i. Inside times inside gives me a negative 4i. And last times last gives me negative 3i squared. I's work just the same as if we had variables. So then if we want to put this in standard form, we put our I squares first, so negative 3i squared. We combine our 6i and 4i, that becomes 2i. And we have our 8 that just hangs out in the back. Okay, so let's do another one. So 3 plus 2a times 3 minus 2a. So we're going to FOIL. So first times first gives me 9. Outside times outside gives me negative 6i. Inside times inside gives me positive 6i. And last times last gives me negative 4i squared. So write them in order from biggest coefficient, or biggest exponent to smallest exponent. So negative 4i squared comes first. Negative 6i plus 6i just cancels. And then we have a plus 9. So negative 4i squared plus 9. Alright, the last thing we're going to look at is complex conjugates. And the complex conjugate just means that we are going to take our a plus bi and we change it to a minus bi. The complex conjugate is just the negative form of that. And then the other thing to note is that when you're multiplying by your complex conjugate, like a plus bi times a minus bi, that just equals a squared plus b squared. Your i's cancel out. Okay, and we are going to do some multiplying of complex conjugates. Okay, so if we look at example 3a, we have 1 plus I. Let's start with what's our complex conjugate of 1 plus I? 1 minus I. Okay, and then we're going to multiply them. So I'm going to take 1 plus I times 1 minus I. And we know that that's going to equal my a squared plus my b squared. Okay, so I can figure out based on this that my a is 1. And then since this is like a 1i, my b is also 1. So if I plug that in, then I get 1 squared plus 1 squared, which ends up being 1 plus 1, which ends up equaling 2. So when I multiply by my complex conjugate, I end up getting 2. So let's do the same thing for 4 minus 3i. So if I have 4 minus 3i, what's going to be my complex conjugate? 4 plus 3i. So then if I go to multiply that, it's going to equal a squared plus b squared. So then my a is equal to 4, and my b is equal to negative 3. So then a squared would be 4 squared, b squared would be negative 3 squared. 4 squared is 16. Negative 3 squared is positive 9. And 16 plus 9 equals 25. Okay, so you guys are going to do 9 through 12, 21 through 24, 31 through 34, and 41 through 44.